is a three-sided shape, so we might say it's a closed shape, meaning it has to touch on all parts. It can't just be open. A closed shape that has three angles and three sides. Okay, I lied when I said we're going to use color pencils, but we're going to just use our highlighter just for a second. So if you want to grab one highlighter, doesn't matter the color. So triangle, what tells me that it's going to have three angles? Try. Did you guys ever notice that triangle literally means three angles? That's what the whole name means. It means three angles. And because it has three angles, that means it has three sides. You guys don't seem very excited about that fact. I'm very excited about that. Guys, triangle literally means three angles. Thank you. That was a little more what I was expecting. Alright, so we're going to classify triangles today. Classify means to name or to sort, to put things into groups. And there's two ways that we can classify triangles. One way is by their angles. So we classify by angles. There's four ways that we can classify by angles. So I'm going to just kind of make a four table here. I don't know how to call that. A little table with four spots because there's four ways by angles. All right, one type of triangle is a triangle that we all really know well, and that is a right triangle. What is a right triangle? Or what makes a triangle a right triangle? What's a right angle? 90 degrees, yeah. So it's a right triangle is a triangle that has a 90-degree angle. So to show that it's 90 degrees, we use the little symbol, that little square, that box in the corner. Okay, how many right angles are there in the triangle? In the triangle? There's just one right angle. I think I said four. I don't know. Okay, so that means that we have one angle that is 90 degrees or equals 90 degrees. So I'm going to use just a red colored pencil here. I'm going to kind of highlight that 90-degree box. And that we have that equals 90 degrees. If you wanted to, you could also use a highlighter here, maybe a different color than the one we just used. All right, another type of triangle that we have is an obtuse triangle. Now we talked about obtuse back when we did 1-4, way back in chapter 1, so it's been a little while. What does obtuse mean again? Yeah, I'm sure you deserved it, but also yeah. Obtuse means what? Good, bigger than 90. So we're going to have an angle bigger than 90. So remember 90 is kind of that straight up and down, so I'm going to just kind of do an open angle to start this one. And then close that triangle off. So in our obtuse triangle, how many angles are bigger than 90? 1, 2, or all three? Just the one. We just have one angle here. I'm going to highlight that with my brown. It's kind of red on the screen, but it's brown. And it's that we have one angle that is more than 90 degrees. So we might see it as a drawing that it's more than 90 degrees. We can kind of all picture that 90 degrees is straight up. So you might see that it's more open, or it might be labeled with a degree that's bigger than 90. All right, so if we have right and obtuse, what one are we maybe missing? What's our other type of angle? Acute. Okay, so our last one we have, not last one, we have two more. We have acute. Acute means what again? Good, smaller than 90. So this can be really, I really struggle drawing these triangles. They're a little bit harder for me. Because to draw them all less than 90, I have to start with a small angle. And then I have to make sure that those are also small angles. All right, so in an acute triangle, all three angles and all is a really important part there. All three angles are less than 90. All right, we have one more type, and this is a type of an acute triangle. It's technically acute, it's just a little bit more specific, similar to like how we say we have eagles, right? But then there's bald eagles and there's golden eagles. It's more specific. It's getting into that more in-depth. So for acute, a more in-depth would be an equiangular or equiangular. When we say equiangular, what part tells us, or what's our prefix for that? How does that word start? Equa. What do you think that means? E-Q-U-I. That they are equal. They're the same. So when I draw this triangle, I'm saying that all the angles are the same. So this angle, I don't know, I did two arcs, but I did. IDK. Just like it when there's two arcs. Looks better than one, in my opinion. Okay, that one is the same as this one, which is the same as this one. Okay, so all three angles are equal. So again, if you want to underline that, all of the angles are equal. And we're going to talk tomorrow about our angles and their measurements, but today we know if they're all equal, that means that they're each equal to 60 degrees. Okay, our only way to make it an equal angular triangle is if they're all 60 degrees. We'll talk about that a little bit more tomorrow, why that's all 60 degrees. Alright, so that's one way to classify triangles, is by their angles. The other way to classify triangles is by their side lengths. Now, you're probably like, Miss Morrell, why the heck are we learning this? One, triangles are kind of everywhere. They're a pretty big piece if you're going to do any building of any sort. Triangles, actually, that's how like all coding works, is like that's how when graphics are put together, it's all based on triangles and movement. It's really in architecture a lot. It's in any sort of engineering a lot. But we need to know the names of these things so that we can apply different theorems to them and get those ideas, big ideas. All right, so side lengths. For our side lengths, there's only 3, so I'm going to just kind of create columns like this going across, 1, 2, 3. Alright, so we have 3 different types of triangles based on their side lengths. One is a scalene triangle. Now, scalene and these words are all going to be Latin bases. So if you're like, what the heck? Who came up with that word? The Greeks did. The Greeks were really, really obsessed with triangles because the Greeks were really obsessed with perfection. So if you're interested in like any art history, like that's why the Greeks, they drew like so many bodies, and all these bodies were beautiful and they're amazing because they're obsessed with perfection. And in the Greek philosophy, the triangles were the perfect shape. They're how we could break every shape down into smaller shapes were by triangles. So if you're like, where the heck are some of these words coming from? It's because they're Latin, because it's based in the Greek ideas. They did a lot of work with triangles. All right, so scalene, we're going to have 3 sides are all different lengths. So it can be a little challenging to try and draw, but the 3 sides are different. Mine looks a little bit too much the same. I should have opened that a little bit. There we go. Okay, so 3 sides are different. So if you're wanting to use some colors here, you could use 3 different colors, if that makes you happy, to show that this side is different than this side, which is different from this side. So if it makes you happy to make those all 3 different colors, go for it. If you're like, I got it, you don't have to. It's your choice. Your notes. So this way when we name it, it's called scalene. Lean is this part, so it's scalene. Our next one is called isosceles. This one's spelled a little bit different. Isosceles. I-S-O-S. Isos, and then celes, C-E-L-E-S, isosceles. Okay, an isosceles means that we have a triangle where 2 of the sides are the same length. So I kind of usually make an A shape, because then those 2 are the same shape, or same size, and then connect. Okay, so in this one we have 2 equal sides. So if we're going to have 2 equal sides, we can mark them. Does anyone remember, how do we mark 2 segments the same? Angles, we use the arcs. What do we do for segments and lines? A tick mark. Good. So a tick mark and a tick mark. So those sides are the same. So if you want to show that they're the same by using the same color for them, you could. Saying that this is the same as this. And this one's different. As we work through isosceles, we'll talk a little bit more about them in 4-6. They get their own separate lesson, isosceles triangles, because they're super cool. But the sides that are the same are called legs. So the sides that are the same are called legs. And the side that's different is called a base. Now, generally speaking, if we're drawing it or when we think of base, we might think of base as the bottom. But the base isn't always the bottom. It's just the side that's different. All right, so if we have all sides are different, 3 sides are different, then we have 2 sides are equal, 1 side different. What's going to be our last one going to be? All 3 are equal, which is called an equilateral, which is probably one that you've heard before, an equilateral triangle. Very similar to equiangular. Starts with that prefix equi. Which means equal. And then it has lateral. Lateral, if you think about lateral movements, lateral is side to side. So lateral means side. Like if you do lateral lunges at the gym, you're doing lunges side to side. So lateral is to your sides. So equal sides. So as we draw that triangle, I want to communicate to my reader that all the tick marks are the same, so I'm going to do tick marks on all the sides. I'll do 2 this time. Just keep it interesting. And this is all 3 sides equal. All right, again, equilateral is going to have their own lesson eventually when we get to the end of chapter 4. But what we're going to find out about equilateral because of some theorems, equilateral and equiangular are always together. So if you see a triangle that is an equilateral triangle, you know that it's also equiangular. Or vice versa. If you know something's equiangular, then you know it's also equilateral. These 2 are always paired together. Always, always, always. All right, last little part. Just one quick note. When we classify a triangle with both names, little did you know triangles have a first name and a last name. I could call a triangle just scalene, or I could call a triangle just obtuse. But to call it by its full name, I need to use both a side length, both one of these, and one of these. And the proper way to do it would be to say the angle name first, and then the side name, and then follow it by that word triangle. So it's kind of like how each of you have your own name. It wouldn't be wrong to call you by your last name and then first name. You could call me Morel Elise. It just doesn't sound right. My name's Elise Morel. Okay, same thing with these triangles. If you say scalene obtuse, it's not wrong. We get the idea. But when we name it with both, we want to name it first with an angle, so like obtuse scalene or acute isosceles. Okay, we always start with the angle name and then the side name. All right, we are going to do a Blue Kit for this first one. So everyone's going to take out their notes, or sorry,